Hello. Everybody's entering the class. Let me and chat. Okay. About half people are here. Still, and a bunch of people are still entering. Okay. Does everybody hear me? Does everything seem fine?
Yes.
Okay. I'm going to switch to screen sharing. And you should see today's reading. Okay, you should see the desktop now. Okay. Okay, so we're going to pick up where we left off on Tuesday. We're going to talk a little bit more about turtles, and then we're also going to start talking about another kind of object. Besides talking about turtle objects, we're going to talk about these things called string objects. We worked with strings, but now we're going to look at them from another point of view. So we're going to look a little bit more at the turtle, and then we're going to look at these string objects. I've given you a short reading assignment for Thursday, 2 more sections in this chapter. And then there's some problems at the end of the chapter, some more of these mixed up coding problems involving the turtle and strings. Okay, most of these involve strings, what we're going to talk about today. And then there's 6 problems on that page. And then here's some more homework problems where you actually have to write the code. So I ask you to do 3 of these. Okay, so 2, 3, and 4. Okay, so that's practicing with what we've been doing. So that's practice. It's not so much, they don't use the turtle so much in these review problems. The review problems are mostly using the strings. Same idea, but instead of using the turtle, they chose to use just strings for the review problems. Okay, so let's go back to the section on the turtle. I just want to, well, actually, okay, here's the code that we wrote last time. Whoops, did I forget to put it up on the website? Huh. I probably forgot to copy that folder. Yeah, I forgot to copy that folder to the website. Okay, so let me get it off of my computer. So I have it. I'll put it up there. I'll try after class. I'll try to remember to make sure that code we wrote last week is up there.
Isn't
So
it in that new Dr. Java file you made?
the example, no, not I'm talking about just the turtle code we wrote. This one here. Here, let me copy it to my desktop. I meant this is what we did in class. This is the code we did in class on last Thursday. Oh, okay. Now, yeah, let me point out, I forgot, I should have mentioned that. I put another version of the CS123 folder up on the website. Okay, if you can download this, okay, and if you unzip it, it's got some new stuff in it that wasn't in there before. So if you extract it, it's got a configuration file. And in the configuration file is a way of making a light and a dark mode for Dr. Java and the turtle code. So you can run turtle graphics code in Dr. Java. So, and then in order to use these configurations, you have to use, instead of double clicking on Dr. Java here, you double click on Dr. Java using these 2 commands to start Dr. Java in the dark mode or start Dr. Java in the light mode. Now this folder should be copied to your C drive, which I've already done it here. So there's that folder copied to my C drive. Okay, so you copy that folder to your C drive, and instead of starting Dr. Java this way, you start Dr. Java by clicking on this. And that starts Dr. Java in a light mode. And here's what some code looks like in it. Okay. And this other one starts Dr. Java up in a dark mode. And here's what code looks like in it. Okay. So you can, now Dr. Java doesn't have an ability to switch between these. So I had to create shortcuts to start it in with one way or the other. The way this works is if you go here to edit preferences, colors, you can set the colors that Dr. Java uses. Like this version of Dr. Java is using these colors. On the other hand, this other version of Dr. Java, I've got it configured to use a different set of colors. See, it's using this set of colors. So this is the palette of colors for this version of Dr. Java. This is the palette of colors for this version of Dr. Java. Dr. Java saves the color palette in a config file. Okay, so that's in here. This is where Dr. Java is saving the dark colors, and this is where it's saving the light colors. It can't save two sets of colors, so I created two sets of config files, one for each set of colors. Dr. Java only knows how to remember one set of colors at a time. So I created two config files. Then this little script here, if you open it to look at what's in it, it runs Dr. Java using one of the config files, and the other one runs Dr. Java using the other config file. So this is a trick to get around Dr. Java's limitations. It can only remember one color scheme, so I give it two different config files and point it at each of the config files. And that way I can get, with two different config files, I can get two different color schemes. So that's a little of a trick, okay? So if you start Dr. Java with these two files, you can choose whether to start in dark mode or light mode, okay? The actual mode is stored in here. And another thing, if you're curious, what I'm using is there's a color scheme called Solarized. This is a color scheme that a lot of programming environments use. It was invented by this guy here. He's the guy who developed it. And it's a color scheme using this palette of colors. That's the palette. You do dark mode by using these colors starting here, going to the left. You use light mode by starting with this color and moving to the left. So you either start here with your darkest color and move this way in the dark mode, or you start here as the background color and move this way for the light mode. So here's what they look like: light mode, dark mode. And what he invented was a color scheme that does both modes complementary. You can switch between light and dark in a sense in a complementary way. A lot of people like it that you're essentially using the same color scheme but in two different ways. So I'm using his color scheme in Dr. Java, and it works reasonably well. Yeah, you can try it and see if you like it. I think it'll work fine on everyone's computer. Okay, in this mode, I'm using a font. Now go back to the preferences. Instead of looking at colors, look at font. I'm using a font called Consolas. I think it's on all your computers. I think Consolas is on everyone's computer, but it might not be, okay? So I think it's on everyone's computers. If your fonts don't, if the letters don't look nice and sharp and clear like this, then you've got the wrong font. Like, let me show you what can go wrong. This is kind of interesting. As you learn to program, you'll start learning to do more and more configuring. So let me change the font. Try to remember what I want to switch to. I want to switch to the font used in this one. The font used in this one is Courier New, okay? And it looks fine. That's Courier New. Over here, let me switch to Courier New. I'm missing, is it? Oh, there it is. Okay. I'm going to switch to Courier New, and it does not look fine. For example, let me change that 5 to a 2. Look at that 2. It's almost unreadable. There's something wrong. This font won't work in this color scheme, but the font works fine in this color scheme over here, which is odd. I'm not even sure why this is the case. Some fonts don't work well in some color schemes. So I switched this color scheme to use a different font than this one. But you have to look at, if your computer is missing the font I choose, it might substitute some other font, and then you get something that's not real. Notice it's not as sharp as it was before. Okay, so, but this font works. This is the same font I'm using in my other text editor. I use this font in a lot of places, and it worked fine in this color scheme over here, but it didn't work in this color scheme. But in this color scheme, this Consolis font worked real well. But I think Consolis is on everyone's computer. See, it looks great. The Consolis, and you can even switch this one to Consolis if you want. It looks nice over here too. Yeah, so if you want, you could go over here and switch this one to the Consolis font. It looks very good over here too, if you have the font on your computer. I bet you do, but I'm not positive. Okay, so now I'm using the same font on both color schemes. Okay. Sometimes when you make a little change, it doesn't know, like why would a font that works in this color scheme not work in this color scheme? I don't even have an answer to that. I'm not sure why. I was surprised. That's the first time I've ever seen that happen. But definitely, it might even be a fault of Dr. Java. It might be that somehow Dr. Java is not handling the font properly. But that one font didn't look good in this color scheme. So, but this font looks great. Okay. Notice that there's lots of little things you have to tweak to get things to work sometimes when you're doing programming. Okay, so programming involves a lot of ideas. So, but I configured this for you so you can choose whether you want to work in this mode or this mode. It is a lot nicer than the previous version. Having a nice color scheme like this is better than the previous version. Okay, now I also made it so that in this version of Dr. Java, you can take the turtle code. You can now take the turtle code and run it in Dr. Java. So now the turtle code now you do get a couple warnings. Their code is old, so these warnings are to be ignored. So I'll see if I can fix that too. But their turtle code's a little bit old, so it generates warnings in Dr. Java. Okay, so their turtle code needs to be updated. I need to update a few lines of their turtle code, but it compiles and it runs. There's my 2 worlds. Remember we did 2 worlds. There's the 2 worlds, and there's the turtles in the 2 worlds. Okay, so you can run turtle code directly in Dr. Java if you want. Okay, so any turtle code can be copied and pasted now from back and forth. You can be, where is it? Here's where the turtle code came from. You can copy and paste anything from here, from one of their windows, directly into Dr. Java now. And if you write some turtle code in Dr. Java, you can try it out in their window also. So you can run turtle code in either place now. Their turtle code, remember the output shows down below. This is one of yesterday's class. Their code, this website was running very slowly. So if you run into the problem that their website running real slowly, you might want to run your turtle code in Dr. Java because it won't be slow. So their world appears as a sub window. In Dr. Java, the world appears as a separate window. Okay, see, the world just pops up as a separate window. Each world is its own window. Okay. All right. So now we got a more sophisticated version of Dr. Java. It has a nice color scheme. You can choose which color scheme you prefer, and you can run turtle code. Now, if any, and one thing I do, last thing I'm going to show you that I do is Here's the folder. It should be on your C drive. Okay. Here's the two scripts that start Dr. Java using the light and dark mode that's in here. I created shortcuts to those scripts on my desktop. You can just create a shortcut, and these shortcuts will work too. So you don't have to go, you don't even have to have this folder open if you don't want to. So you can just create a shortcut to that script, that file there. You create a shortcut to that file there, and you can put it anywhere you want, and then you can start Dr. Java this way. Okay, so you can put a shortcut to these scripts anywhere you want. You can start Dr. Java from anywhere you want. Okay. Okay. So I have I have a light mode and a dark mode shortcut on the desktop. Okay. All right. Then if you create these shortcuts, you can just kind of forget this folder here. This folder can just sit on your C drive. You can leave this folder alone, and you can put these shortcuts in your homework folder. The idea, I think the good idea is to put a shortcut like one of these in your homework folder, so you can start Dr. Java up in your homework folder and keep your code in a homework folder. This is not a good place for you to put your homework code over here. Okay. Any question about what I did here to create like a new version of Dr. Java? Oh, and what I named it, I gave it the name CS123 version 2, so it wouldn't clobber your previous version. If you're just, if you don't want to clobber that version, you can keep these side by side. So there's the old version of Dr. Java. And this one should start up. Let's see. Oh, I see. This one's tricked into starting up in dark mode. I'm not even sure why that is. Somehow Dr. Java now defaults to the dark mode, and I don't even really know why that is. I'm not sure why this previous older version is now defaulting to dark mode. I think whatever. That may not be the case on your computer. I think I did something. I think I may have copied the dark mode over to this one by accident. Okay, but I purposely named the new one version 2 so it wouldn't clobber your old one. So if your old one's working and you want to try this one, you can put them side by side. You don't have to worry about, you shouldn't have them interfering with each other. Okay. Let's see. Okay, so for today, so that's this link here, the new version of Dr. Java. I think it'd be a good idea to I think you should download it because it's got the turtle code in it. So I think if you want to work with turtle code in Dr. Java, which probably is going to be faster than their website. I mean, yesterday, their website, the website for this book was really running slow yesterday. So it's kind of annoying. So if you don't want to have the problem of worrying about their website being slow, you can run your turtle code directly in Dr. Java now. Okay. Okay. So definitely try it. If anything seems funny, if you download this version of Dr. Java and it doesn't look right, the color modes somehow don't seem right, there could be some little glitch. I mean, this stuff is hard to get working on lots of different versions of Windows and Macs and Linux. So there's always a chance, like I didn't create scripts for Macs. If you have a Mac and you want to use the light and dark mode, we may have to figure out how to, I'm sure it'll work in a Mac, but you can't just double click on those shortcuts. On a Mac, you cannot just double click on these two. We need to create a Mac version of these two. So the config files in here should work on a Mac, but these won't work on a Mac. Same with Linux. These won't work on Linux, but the config files will work, and this jar file will work on Mac and Linux, but not these guys here. So if you've got a Mac or a Linux, you might have to send me an email and we can straighten out how to get these two things working. Okay. Okay. Any question about this thing here? Okay. All right. So I want to play around a little bit more with something about the turtle code. Okay. Now let me open the other turtle code in Dr. Java. Here's the code that we wrote here's the example code we did last week. And I got to get this up on the website. This is the code that has the broken link to it on the website. Right now, this is supposed to be that, which is a broken link. I didn't check it after I made it. I didn't check it. So this is the code we wrote last week. Okay. Notice, remember, we created more than one turtle. We created a turtle called Yertle and a turtle called Y2. Okay. And actually, even here's a third turtle, but this third turtle is in a different world. So I created two worlds. Now, I want to talk about what we call a memory diagram, a picture of what this looks like. Okay. Remember, we use the Java visualizer to look at what the one textbook referred to as, I'll show you. Let me find it. Let's see. If you go to this book here, chapter 2, there's this section called memory diagrams. Okay. And then also in this book, let me open it up again. Okay. If you go to chapter 4, there's something called stack diagrams. Okay, so we have memory diagrams and stack diagrams, and we use the Java visualizer to create these. And we did those not with we didn't do it with the turtle code. We did it with programs just using int variables and double variables and methods. Okay, so when we did these memory diagrams and the stack diagrams, they were all with variables that were ints and doubles and strings. We didn't do anything with objects. So I want to do a memory diagram with turtles and show you that it's a little bit different than these kinds of memory diagrams. Okay, so this is going to be something that's important that we're going to be doing a lot of. We're going to put a lot of emphasis on these memory diagrams and stack diagrams. So I wanted you to do it with an example here. Okay, so now I want to draw a picture. So I want a program that I can draw pictures with. I'm going to draw a picture as I follow along this code. I'm going to draw the memory diagram that the Java visualizer would. Now, one bad thing is we can't use the turtle code in the Java visualizer. I could put the turtle code into Dr. Java, but I cannot get the turtle code into the Java visualizer. And the book even points that out. The textbook with the turtle code, they mention that they're right here. The code lens visualizer will not work with the graphics program, doesn't work with turtle code. So remember, they called the visualizer code lens, the code lens visualizer. It's the same thing as what we did, the Java visualizer. Okay. Unfortunately, this Java visualizer, which is what they call the code lens, won't work with the turtle graphics. So we can't draw memory diagrams. Remember, the memory diagram was over here. The memory diagram would be drawn in this half of the Java visualizer. This half visualized stepping through your code, and this half drew the picture exactly like the book, like these memory diagrams. And these, actually, the Java visualizer was drawing stack diagrams. Okay, it was drawing the stack diagram over here, and it called them frames because nobody can agree on names. Everyone's going to have a different name for the same thing. So they call them frames over here, and this book, most people call them stack diagrams. They're stacked. This is a frame, and this is a frame, and they're stacked on top of each other. In the Java visualizer, you'd have, this is one frame, there'd be another frame stacked, there'd be a stack of frames over here. Okay, so this little box here was that box there, and then when you ran programs, you got a stack of these boxes. Okay, so the book referred to it as a stack diagram. But we can't use the Java visualizer to draw a stack diagram of turtle code. So I'm going to draw the stack diagram over here myself as we run the turtle code. So I'm going to draw the stack diagram to show you what it would look like. Okay, so here's what it's going to be. Okay, this line of code creates a variable. I need to let's see. Now I've lost what I wanted in the. I want the. Let's see. Oh, yeah. Okay. Okay. When you write, here's what when you execute line 8 of code, you create a variable called world. So there's the little. Let's see. That's too thick. That creates a little box. Okay. That is a variable, just like in the picture in the book. See, you have a little box with a value in it and the name of the variable. Okay, so over here, the name of this variable is world. Okay, so there's the variable that's called world. Now let me ignore the right-hand side for a minute. In this picture over here in this book, that came from this line of code here. Okay. Actually, they got the wrong. Oh no, see, first they created a variable named A. Then they put 5 in it. So there was a 5 in there at first. Then they created a variable named B, and they copied A into B. So the 5 that was in A got copied into B. Then they replaced what was in A with a 3. Now, notice that the picture is the following. There's a box that holds a value, and the box has a name. Okay? That's what a variable is. A variable is a box with a name that holds a value. The name of the box won't change, but the value in the box can change. That's why we call it a variable. So it started out holding a 5. Its value can be copied into another box. Then its value got changed to a 3. So the box its name never changes, but what's inside the box can change. So that's what a variable is. Okay, and the value is put inside of the box. Okay, now see, you have the declaration of the variable on the left-hand side and the value on the right-hand side of the equal sign. Over here, I'm only going to draw the left-hand side for a minute. I'm going to ignore for a minute what's going on the right-hand side because it's a little bit more complicated than the other pictures. Okay, now the next line of code creates another variable. I have another variable, and this one is called Yertle. I'm not going to say what's in Yertle yet. So that's the name of the variable. Okay, we haven't put a value in it. Okay, then I have a third variable here. So I'm going to create a third variable. Okay, and this variable is called y2. This variable is called y2. Okay, so I've got 3 variables. Now, I only looked at the left-hand side here, the left-hand side, the left-hand side, and the left-hand side that created the variables. Now let's move to the right-hand side. These were constructors that constructed objects. So that way we draw a picture of that is over here in the right half of this picture, I'm going to draw the objects. The objects are separate from the variables, and this is what's really different here from over in this thing. The value goes inside the variable. You put the value inside the box of the variable. That's not how objects work. The object sits in memory by itself. So I'm going to go over here. I'm going to draw a picture of an object. So an object's going to sit over here. This is my object, and my object is a world object. Now that's world with a capital W. That's the kind of object it is. Okay, see, this is world with a lowercase w. That's the name of the variable. It's a variable of type world. Just like over here, this is a variable of type int, so the box holds an int. Now we have a variable of type world, but the box does not hold a world object. The world object's over here. Okay. Now, so far I've done the left-hand side of this equation and the right-hand side of this equation. The right-hand side created a world object. Let me drop down to here. This creates a turtle object. So I go over here and I'm going to draw a turtle object. And this is an object of type turtle. So this is a turtle object. Notice that's not the name of a variable. That's the name of, that's the kind of thing it is. This thing is a world. This thing is a turtle. But then I created another turtle here. Okay, so I need another turtle object in my memory diagram because I created 3 variables and 3 objects, 1 world object and 2 turtle objects. So let me draw another turtle object. I'm running out of room. See, I'll put it over here. Here's my other turtle object. And it is another object of, it is a turtle. Okay. Right. So now I've done the 3 left-hand sides and the 3 right-hand sides. Now, what does the equal do? This is the tricky part. This is a very different idea that makes programming different than math. In math and in simple programming, the equal sign copies the value into the variable. So 5 was in that box. Then the value was copied from that box to that box. So the 5 in that box got copied to that box. Then here, a new value got copied into that box. So 3 is in that box. Okay, that's the memory diagram. Okay, what's in a box that represents a object? What it is, it's points. What this variable holds is going to be, I'm going to draw it as a arrow. It's going to hold a, this is how we draw it. It holds an arrow pointing at that object. The variable holds a pointer, a thing that points at the object. Okay. The object's not in this variable. The variable and the object are completely separate things. The variable, in Java, we say it refers to the object. So that variable refers to that object. Then this variable will refer to that turtle object. It points at that turtle. And this one will point at that turtle. Okay. These are what the memory diagrams for objects look like, as opposed to the memory diagrams for what are called primitive variables. Numbers are called primitive variables. What that means is the value sits in the box of the variable. The box is the variable is the box. The variable is not the value. A isn't 3 because A started out holding 5 and ended up holding 3. It isn't, A isn't 3, A holds 3. A is that box. And at any given time, that box is holding some number. That's the value of A. Okay, so don't say that A is 3. You say that A holds 3. A is that little box, and B is this little box, and B holds 5. Over here, world is that box, and world holds a reference to that object. And Yurtle is that box, and Yurtle holds a reference to that turtle. And then this holds a reference to that turtle. Okay? Now, here's something I can add to my code if I wanted to. Okay, let me go over here and add something to this code. I'm gonna delete the second world because I don't really need it in this example. I'm gonna delete the second world. Okay, now I'm gonna create a new turtle variable. I'm gonna call it y3. Okay, now that by itself creates another variable over here. So let me draw the box. It creates a variable. Creates a variable called y3. Okay. Now I haven't made it point at anything yet. I'm going to do the following. Okay. How many turtles do I have? Anyone want to guess how many turtles I have?
3.
3. It turns out that the question is actually ambiguous. How many turtle variables do I have? Yurtle, y2, and y3. But how many turtle objects have I built? Only 2 of them. I've got 3 turtle variables and only 2 turtles. What is in y3? Well, what I did here was I copied from Yurtle to y3. What I actually did was I copied this arrow into here. So what y3 is another name for that turtle. This is weird. This is something you can't do with numbers. You can't have 2 names for the same number, but you can have 2 names for that turtle. Now, what that means, if I send a command to y3, I'm actually moving the Yurtle turtle. Okay, so go over here. Here's a bunch of commands that command Yurtle. Okay, then suppose I say here y3 dot forward 50, y3 dot turn negative 45 degrees, y3 dot forward 200. Okay, all right. All of these commands actually command the same turtle, because what I've actually got now are 2 names, Yurtle and y3, for the same turtle. When you see, you only get an actual turtle thing when you call new turtle. If you create a turtle variable, that doesn't create a turtle object. So it just creates a name. And then initially that name, if, for example, if I actually wrote this in my code and left it like this name would be blank. It would actually hold something we call null, N-U-L-L. It would be a blank or a null name. It wouldn't name anything. It would be a box that didn't hold an arrow. But if I go ahead and set it equal to Yurtle, I'm copying Yurtle's arrow into y3. So now y3 is what we call an alias for Yurtle. Yurtle's now this turtle isn't Yurtle. This turtle is a turtle, and that turtle's got 2 names. So Yurtle and y3 are 2 names for the same turtle object. Any command you send to y3 gets sent to Yurtle. So let me go over here and run this, and we'll see that these commands keep moving the same turtle. and then later on, this other turtle appears. In fact, let me not create this other turtle until, so let me take this code and not even create this turtle until we've done moving Yertle. Okay, so now I create the world and I create Yertle and I give Yertle a second name. I use all these names. The first I use the Yertle name, then I use the Y3 name, but I'm still moving the same turtle. So all this will move the same turtle. Then I'll create the second turtle. And when we see the second turtle appear, that means we stopped using the first turtle and moved to the second one. So compile this. You get a couple warnings. I think I'll try to get rid of those warnings. Okay. Okay. So now let's see. The movement was not real interesting. Let's see. In Dr. Java, when you run these things, actually, this is one difference between Dr. Java and see, they happen almost instantaneously. In fact, let me take this code and put it back in their website. And what's kind of nice in their website, I'm not sure if I can get Dr. Java to do this, is their code runs in steps. See, there's our code now. Okay. Okay, if I run this, it's a little bit slower, but it's kind of nice that it runs it step by step. So there's the turtle. Notice those last commands were actually on the name. See, those last commands were on the Y3 name. Okay, this and this part were the Yertle name. Well, actually, starting over here, up, over, down, point left. That was all done with the Yertle name. Then I switched to the other name, but I was still talking to the same turtle. So I was still talking to the same turtle. And then we got to this line here and created this other turtle and just sent him off this way. So Yertle went up, jumped over. Remember, the code was that we created Yertle, he moved forward, turned left, but then he raised his pen. So when his pen is up, he's not drawing anymore. Then he went forward, then he dropped his pen down, but then he changed his color of his pen to blue. Then he turned left, so he's pointing down here. Then he went forward, then turned 45 degrees, forward some more, and then another 45-degree turn. Oh, and then he actually didn't do anything because he hit the wall here. So he actually, this one should be like a 100 because otherwise he's hitting the wall. No, I'm sorry. Let's make this one -45. So instead of, he turned the other way, move away from the wall, and make this a small. See, it's slower. You have to wait a little longer for this to run. But the nice thing is you can see it run in steps. Okay, so that was Yertle, but you know, from here to here to here was using the name Yertle, then from here to here was using the name Y3. Okay, so I was talking to the same turtle object. It's confusing. I'm talking to the same turtle object here as I am here, which is, a lot of people make this, when people are learning this, they think that this is turtle 1 and turtle 2, that I have two turtles. They look at the left-hand side and think, you have two turtles. So here you're talking to two different turtles. And people forget to look at the right-hand side, which is just as important as the left-hand side. This is saying Yertle is a name for that turtle, But this is saying that Y3 is a name for Yertle. I'm not creating another turtle. So I have my memory diagram. I've got Yertle and Y3 both naming the same turtle. Okay. This is real important. These memory diagrams solve a lot of confusion in programming, in Java programming. Now, last week we said that an object is a bunch of data. And when you call methods on the object, you're updating the data in the object. So, like, what is in these objects? So, for example, the world. Let's fill in. Let's put the data that's in the world. Okay. Now, when you build a world, you say how wide it is. So this world has got in it his width, which is 500, and he's also storing his height, which is 500. And another thing is when you create a turtle, you put him in that world. So this world is remembering that it's got a turtle in it. So it remembers that it's not clear how it does it, but it remembers that it's got a turtle. Okay, so it holds a one turtle. What it actually holds is like what these guys hold. It actually holds an arrow back to that turtle. Okay, so this world object holds one of these arrows back to this turtle over here. So I won't draw it that way, but I'll say this world remembers his width and his height, and he remembers that he's got one turtle. Okay, and then later on, he's going to remember that he's got this other turtle, because then down here, this other turtle is put in that world. So at that point, this thing will remember two turtles. He'll have an arrow to that turtle and an arrow to that turtle. He'll remember that the two turtles that are in his world. Okay. Now, what about a turtle? What does a turtle remember? Okay. Now, we said there's various things that the turtle has his X coordinate, his Y coordinate. I'm not gonna, yeah, that's where he is. He has an X and a Y coordinate. His pen color is stored in there. His pen up, down is stored in there. Whether the pen is up or down is stored in there. So what's another thing does anybody remember what else did we store in a turtle? We mentioned a few other things.
The pen color.
Oh, the pen color I wrote, that's here. Pen color, pen up and down. What else is stored in a turtle?
Turtle color.
The turtle color. We didn't try changing it, but you can actually change the color of the turtle itself, which is different than his pen color. So you can change the color of the turtle itself. What else?
The size.
The size of the turtle, which is, you can make the turtle grow and shrink if you really want to. So the turtle has a size. Anything else? There's one other we changed. We changed it in our code. What's another one we changed that's real important?
Direction.
The direction. Yeah, his heading. What direction is he pointed in? So a turtle remembers where he is, what direction he's pointing in, what's the color of his pen? Is his pen up or down? What's the color of the turtle? What's the size of the turtle? And another thing was the thickness of the pen. We haven't changed all these, but there's also, you can change the pen thickness. I didn't organize this very well, but pen color, pen up and down, pen thickness, turtle location, turtle heading, the turtle color, and the turtle size. Okay. Now, what's interesting is this other turtle holds all that same information, but it's different in his case. So this turtle will have a different location. He'll have a different pen color. He'll have a different state of pen being up or down. He has a different turtle color. I mean, the turtle library made sure that every turtle got a different color. When they're created, they were created with a different color to keep them separate. You can change the size of the turtle. They're all created with one size, but you can change the turtle size. So the idea is that every object carries all this same data. Okay. Now, when you send a forward command when you use this variable here, yurtle, to send a forward command, you're changing the X variable in that turtle. When you send a forward command to yurtle2, now it's the same forward command, but it's on yurtle2. So you type yurtle2 dot forward, you're changing that X variable. If you go to yurtle and say pen up, you're changing his pen up. But if you go to this variable, if you go to this variable and say pen up, you're changing that pen up and down. If you go to this variable and say pen up, it's talking to the same turtle as that variable. Okay, so every turtle holds its own set of data. So this box holds lots of variables. Notice that these are more variables, actually. All the data in a turtle just is more variables. An object is a bundle of variables. So you got a variable over here pointing at an object. The object is a bundle of variables. And then you use methods to change those variables, which make the object, can command the object to do things. Okay. All right. So this is the kind of memory diagram that we're going to be drawing more and more as we go along. We're going to draw memory diagrams using objects, not just simple memory diagrams like this one. This is a simple memory diagram because it's holding what we call primitive variables, numbers. And Boolean is also another primitive variable. The primitive variables are ints and doubles and Booleans. In the case of a primitive variable, the value sits in the box. He only gave examples here of ints, but the values sit in the box. Okay. When you have these variables are called primitive variables. These variables are called reference variables. So Java has two kinds of variables: primitive variables, which are essentially numbers and Booleans, and everything else is a reference variable because they refer to an object. We'll see that strings are an example of a reference variable. A string variable refers to a string object, and the string object is a box holding the letters of the string. So the data in a string object is going to be the letters. Okay? All right. So this is, now in this book here, not this book. In the book with the turtle stuff, if you go look at another section of the book, this chapter in section, I think it's, I can't remember. Let's see I can't remember which section it is. Not section 3. I'm looking for a picture. I want to show you a picture. I can't remember. I cannot remember which section it's in. Now let's see. It's in one. Let's see. Oh, do it again. Not in section 2. There it is. I'm sorry. So it's section 4. Here's a picture that represents not all, but some of the data that's in a turtle. And then see, it also says, but these are the methods that are in the turtle. So in fact, what's in these boxes is not just the data, but we also think of the methods being in the box too. This turtle holds, so this is this is what a turtle object looks like. And this is actually not all of it. There's a little bit more. For example, every turtle can be given a name. That name, be careful, that name is not this variable over here. Turns out you can give a turtle a name that's a string that's stored in here. That's not the name it has as a variable. It can get real confusing. A turtle can hold a string that just gives it a name that's completely separate from the variable name it gets over here as a reference variable. So you can have a string in the turtle that gives it a name. The turtle has a turtle color. The turtle has a size, that's its height and width. That's the size of the turtle. The turtle has a position. Okay, so that's what we talked about, the turtle color, the turtle size, and the turtle position. But then we said there's also a bunch of other things that they didn't put here. The turtle has a heading. The turtle has a pen up, pen down. The turtle, see, we have things here that they didn't put in here, and they have things here we didn't put here. They should have created, I wish they'd had a picture with a complete list of everything that's stored in a turtle. Then here's some of the methods that are in a turtle. Forward changes the XY position, and backward changes the XY position. Turn left, turn right change the heading, which they didn't put in this picture. But turn left and turn right would change the heading. Pen up, pen down would change the pen up, down Boolean. Okay, forward also notice that this is two different versions of forward. Forward without a parameter, which moves you 100 pixel, versus forward with a count of how many pixels to move. And backwards with a count of how many pixels to move. It's different than the backwards that just moves 100 pixels. Okay, then you could set the color. Now this is setting the color of the turtle. Then there's also a set the color of the pen. In our code, let's see, setting the pen color. Oh, I lost my code. Let's see. Yeah, when I jumped to a different page, I lost my code. It's here. Setting the pen color. Oh no, that does set the pen color. So that's not setting the turtle color. This one sets the pen color. Yeah. And then there is a separate color for the body of the, unless they they said body color. I suppose they mean the color of the turtle itself, not the color of his pen. So there's a body color and a pen color. Set color changes the pen color. Then there's another method that changes the body color. Later on, we'll see where we can look up these methods. So this is kind of an incomplete reference. But this box represents a turtle in memory. So that box is this turtle object. Every turtle object has all that stuff in it. So every turtle object in memory has all this stuff and more, because we just said there's really more than just this in the turtle object. The turtle object has a lot more variables, it remembers, it keeps track of a lot more things than just these. Okay, so every turtle object has a copy of all this data. And when you call a method on a turtle, each turtle updates his own data. You cannot tell one turtle to change the data on another turtle. The Java language doesn't allow one object to make changes in another object. Okay, so if you want to change things in that turtle, you have to use a reference to the turtle. You have to get a reference to the turtle and call a method on that reference that'll change things in that specific turtle. If you want to change things in that turtle, you have to have a reference to that turtle. You can't somehow have one turtle make changes in another turtle. They're isolated from each other. They are, in a sense, they're not clones of each other, because they have all the same pieces of data in them, but they're holding different values. The location of this turtle is going to be different than the location of this turtle. The pen color of this turtle could be different than the pen color of this turtle. This turtle's pen can be down while this turtle's pen can be up. Okay, so these kinds of diagrams are going to be real important to us. And the book doesn't actually draw a diagram like this. It shows you this picture here. The data is called attributes. This is a fancy word people use. I mean, I just like to call it the data in the turtle, but a lot of people like to use the word attributes, the attributes of the turtle. What's his color attribute? And then the methods. We call these the methods. So we all use the word method to mean these methods that you call the method to change. Each method usually changes a specific attribute. Not always. Sometimes a method will change more than one attribute, but usually each method affects one attribute up here, okay? Like turn will affect only the heading attribute, okay? And pen up will only change the up-down attribute. Forward, though, changes both the X and Y coordinates. If you're headed at a 45-degree angle and you move forward, you have to change both X and Y. If your heading is east and you move forward, you only change X. If your heading is north and you move forward, you only change Y. But if your heading is 45 degrees and you move forward, you change both X and Y. Okay, so sometimes a method can change more than one attribute. All right, so these memory diagrams are going to be real important. Now let's switch to a different kind of object. Let's switch to, instead of playing with turtles, let's play with strings. Now let me save this. I don't want to lose it. Okay, so here's my turtle memory diagram. Okay, now I'm going to switch to strings. Now, the nice thing about strings is I can go over here to the Java visualizer and I can show you string objects with real memory and have the Java visualizer create the memory diagrams. So I'm going to create a string S1 and put the string hello in it. And I'm going to create the string S2 and put the word goodbye in it. Okay. And now, like I did with turtles, I'm going to create a string S3. And then I'm going to put S1 in it. Okay. Now, notice I don't have to use the word new to create a string object. Java, actually, I could do the following. This is redundant, but Java, this here is shorthand for this. Now, with turtles, we have to create the turtles by saying new turtle. Java, we work with strings so much in Java that Java lets us just type the string itself without saying new string. Okay, but that creates a string object, that creates a string object. I have 3 string reference variables, but we're going to see in the picture that I'm going to only have 2 string objects. Okay, now move forward. Now, here's a problem. The Java visualizer is not drawing things the way I said it would. It drew these like they were primitive variables. That's a quirk of the Java visualizer. I'm not sure why they chose to do that. Now watch, I can change that though. I go to options and I say show string not as values. I don't know why in the world the people who wrote the Java visualizer did it the way they did it. They should have had this checked automatically. Okay, the way it's done right now is very misleading. What would happen? It's lost. I'm going to refresh the page. Okay, I'm going to refresh the page and paste my code back in it. Okay, now this is the default way of doing things. The default way of doing things, draw bad pictures. This is not good. This is not how you should think about strings in Java. There are not 2 hellos. So I go back here, and I click option, and we're going to always do this with the Java visualizer. Check that box there. Now we're going to get pictures like we should get. S1 points at a string. Notice that this is like I drew here. I've got a variable called world points to a world object. I've got a variable called Yertle points to a turtle object. I've got a variable called S1. Over here is the string object. See, I said these is a turtle object and a world object. This is a string object. They don't draw the little box around it. The data in the string are the letters HELLO. Okay. If I go forward, I get another string object. Okay. Now watch what happens when I go forward to this one. I get two arrows pointing at the same string object, just like we did here. Two arrows pointing at the same turtle object. I have two arrows pointing at the same turtle. Notice that the concept of an object is what we're getting at here. It doesn't matter if they are turtle variables pointing at turtle objects or string variables pointing at string objects. The idea is still the same. The variable doesn't hold the data, it holds an arrow. Even, that's how they even highlight the arrow if you hover over it. The variable holds an arrow to the object. The objects see how they tell you that frames mean variables, objects are over here. Over here, I would have said frame over here, objects over here. There's a sort of a dividing line here between the variables and the objects. And over here, they don't draw it, but there's a dividing line between the variables and the objects. Okay, now, got a couple more minutes. Now, I haven't called any methods on these objects. Okay, so let me call a method on this object. Now, here's something kind of quirky. Suppose I take string 1. A method I can call on it is toUpperCase. Okay. Now, in the case of turtles, when I say Yertle, move forward 200, the object that I'm pointing at, okay, Yertle points to that object, and that object changes himself to being in a new location. So that changes the position of the object by 200. So this number and this number would change depending on, depending on the direction Yertle's pointing at. When I move him forward, I might change X, I might change Y, or I might change both of them, but this changes. Okay, strings don't work that way. Strings are a little bit quirky. Okay, I'm about to execute this line. S1 is HELLO. I click forward, and nothing happened to S1. S1 did not become uppercase, even though I said toUpperCase. Here's how Java works. Strings never change themselves. Once you create a string, it never changes. Here's what happens. Well, when I call toUpperCase on S1, what this object does is he makes a copy of himself. And he makes a copy of himself with all of the letters uppercase. And then he gives me back the copy, which I give it the name S4. This is tricky. S1 doesn't modify himself. S1 makes a copy of himself and modifies the copy. That's not what turtles do. Turtles modify themselves. When you call forward on a turtle, the turtle changes its data. When you call a method on a string, this is a special kind of object in Java. The string objects never change themselves. They always make a copy. Let's visualize it. Okay, now I'm about to call, what I'm doing is this guy's going to create a copy of himself. So there's going to be a new string down here. And then I had to give a name to that new string so that I could see it. Okay, so this guy did this work. I was pointing at S1, which is this string. I said to this string toUpperCase. So this string said, okay, I'll raise all my letters to uppercase, but I put them in a new string. And then it gave me back a pointer to that new string, which I stored. Okay, this is why we have to learn programming real carefully. This stuff can be weirdly tricky. Okay, and why would turtles work? Okay, it's object-oriented programming, but methods on turtles work very differently than methods on strings. Methods on turtles modify the turtle. That turtle changes its internal data when you call these methods. Strings won't do that. Strings, when you call methods on them, always make a copy of themselves and give you back the copy with the changes in it. Okay, there's technical reasons why Java works this way, but that's how they chose to make Java. They chose to make strings act differently than other objects. They never change themselves. Turtles always change themselves. Strings never change themselves. Every method on a turtle changes something in the turtle. Every method on a turtle changes some data in the turtle. Every method on a string creates a new string and gives you the new string with the change made in the new string. Okay, so that's a quirk of strings. Okay, all right. So, no, but notice that when we work with string objects, we get these nice memory diagrams. The Java visualizer gives us the memory diagram. Unfortunately, the Java visualizer will not work with turtles, so we have to draw our own memory diagrams when we write turtle code. If we want to think about what the turtle code is doing, we have to draw our own memory diagrams. As you learn to program, you need to draw memory diagrams. I can write code that you will not be able to figure out what it's doing if you don't draw a picture of what it does. The code can be pretty confusing. And very often, the way to sort out what code is doing is to start sketching a memory diagram and keeping track of who is naming what objects. Okay, who names which objects? See, notice I can have multiple names to the same object. You might say, why bother doing this? Why would you ever want to give that turtle two names? And we'll see that Java does it all the time. It's real common to give an object more than one name. And we'll see why that is. So since an object can have more than one name, and it's common for that to be the case, you need memory diagrams to keep score of which names are referring to which objects, so that you know that a method call on that object does the same thing as a method call on that. A method call on that variable does the same thing as a method call on that variable, because they're pointing at the same object. Okay, so these memory diagrams are incredibly important because they help us sort out tricky code. Without them, tricky code can be really tricky to understand. Many, even experienced programmers, goof this up, and they look at code like this and they think, oh, that's a turtle and that's a turtle. I got two different turtles, and I don't, because that line did not create a new turtle. It just said this guy's a name for that turtle. Okay, but it's very easy. Now, for example, there are programming languages where this line creates a second turtle. Okay, there are languages that work that way. Okay, Java doesn't, but there are languages where, oh, this turtle is a copy of that turtle, but it's a different turtle, but a copy of that. So you have to know the language you're working in, because that line of code, what it does in Java, you can write that same line of code in C++ and it'll do something a little bit different. It'll be the same, it'll look a lot. C++ and Java look alike, but they don't act alike. Same thing with JavaScript. That line of code could be JavaScript for all you know. JavaScript code would look like that, but it might do something different than what Java does. So the same looking line of code can have different meanings in different languages. So just because you know one language doesn't mean that you see that line of code in Java and you see that line of code in JavaScript and you think, I know what it does. And it turns out you don't. That each language can give that line whatever meaning it wants to. Java gives it the meaning that you create a new variable. That's this guy. Then you copy this arrow into that variable. So you don't create a new turtle object, you're just creating a new turtle variable. And that new turtle variable is just another name for that previous turtle object. So now this turtle object's got two names. That turtle object is named Yertle and Y3. It's very subtle, and we have to learn how to decipher these steps. We have to, and the trick is to draw a picture. You know what the code is doing if you can draw a picture of what the code is doing. And if you want to understand how Java might work differently than JavaScript or C++, you take what look like the same lines of code, but you draw the appropriate picture for each language, and you see that they can do, each language will treat these lines of code slightly differently. Okay? All right. Now, oh, we run out of time. Okay. Run out of time. Does anybody have a question about what we've just done? Anytime you have questions, just shout them out too. So if I say something and it seems like it doesn't make sense, you can unmute yourself anytime and shout out a question. Anybody have a question before we quit? Okay, I'll save these pictures, and let's see. So we've talked about everything in these objects. We haven't talked about all the methods in the string class. I'll just show you. Read this section. There are a lot of methods in the string class. I can't remember if they give you a list of them here. No, they don't even give you. I'll give you a list of the important methods in the string class. Okay, so they give you a little baby list here of methods. There's a real useful list of methods that the string class has like about 100 methods in it, but there's a short list of very important methods that we're going to keep using on the string class. So I'll give you a list of the methods on the string class. So we pretty much talked about everything that's in these sections and these sections. And on Thursday, we'll talk about, we'll keep talking, we'll go over the variety of methods in the string class. I'll show you a list of real interesting methods that are useful in the string class. And then we'll start talking about this thing called the math class. And that'll be the end of this chapter 2. Then we'll go on to another topic in programming. We're going to start talking about if statements. After the next reading will be about if statements. So on Thursday, we'll finish talking about the string class, and we'll talk a little bit about the math class. Any last question before I stop? Anything? Okay, so start reading those sections. Try these problems. If you have questions about the problems, we can do them in class. If something seems hard here, if this seems easy, great. If this seems hard, ask about it. I hope that by now that these things look pretty easy, but you have to find out. You have to try them. If you try them and they seem easy, great. That's what you want. Then you're understanding everything we're doing. If you try them and they seem difficult, you really need to ask. Okay. Okay. So I'm going to go ahead and stop sharing. And any last question? Okay. If you have questions, send me email. See you on Thursday. I'll go ahead and end the evening now. See you on Thursday. Bye.